Hi everyone, my name is Shane, and today I'm going to be talking to you about what is cloud. Just going to try and clarify things for you and just put it in a simple sort of explanation. So, essentially, what is cloud? Really, today it's using the internet. Um, it's using the internet to do things from an electronic device, a web-enabled device. So whether it's a laptop, computer, smartphone, or tablet, if this can connect to the internet, effectively you're going to be able to use cloud computing. Um, and really, it's a gateway using the internet to do things that you perhaps couldn't on your device, or it takes just some of the stress off your physical device and does these operations somewhere else. So, in a nutshell, cloud computing uses the internet as a gateway to other computers and services to do the work for you external to your device. And if we think of the kind of services that we can get from the cloud, we can actually think of a lot of everyday internet sort of things we do on the internet, such as we use webmail, such as Gmail or Hotmail. We use cloud storage when we're using Dropbox or OneDrive. We're using social clouds when we use networking sites like Facebook and Twitter, and even music services such as Spotify. So instead of storing files locally, instead of performing complex calculations or operations actually all on your device, it's actually taking place somewhere else in a server farm or a data center, and you're just getting this information through your device through the internet. And this is cloud computing. So we can actually abstract this into three distinct areas. The first one being the front end, which is the physical device. The front end is what you see as a user. Um, then we have the middle end and the back. The middle is sort of like the network, the interface between the front end and the back end. Really, the front end connects to the back end through a network or through the internet. And the middle layer just sort of orchestrates or architects sort of the traffic that goes through there. And then the back end is where the actual cloud sits. So let's have a look at these in a little bit more detail. So as I said, the front end is essentially your computer. It's what you as a user use to connect to the internet. It can be computer, tablet, smartphone, etc. Now, you can use, for example, install applications on your device. And these applications give you access to cloud services because these applications actually access through the internet the cloud system, such as, for example, YouTube. All those YouTube videos that you watch are actually stored somewhere else in YouTube's data center. You just stream them through the internet to watch on your device. The same thing happens with Spotify or Facebook. These allow you access to the content from the provider through an application. And a web browser pretty much acts the same way. Um, for example, Internet Explorer, Firefox, or Google Chrome. These give you access to cloud services such as web-based email like Gmail or online storage services such as Dropbox through your web browser. Now, the middle layer, as I explained, connects the front end to the back end, but it's also a little bit more complex than that. And how it works is there's software installed um, pretty much in the back and the front end, and they need to communicate with each other. So the middle layer is used to ensure that the language is understood. So there's usually a central server, which is like an administrator, and it follows a specific set of rules known as protocols to ensure everything flows smoothly. So you can think of the middle layer as like a conductor at an orchestra who's sitting in between the audience and the band members and making sure that the audience likes what the band is playing and the band is actually doing what they're supposed to and the audience is enjoying the music. So it's keeping harmony there. And this, like I said, the front end connects to the back end through the internet. This could also be known as the information highway, and pretty much any sort of exchanges of information that occur through the internet happens over what's called packets. So information is broken down into small packets and then sent through the internet. And this is sent according to rules and protocols known as transmission control protocol and IP internet protocol address. So pretty much just identifies the device that you have and what kind of information you're going to be receiving from the internet. And then we have the back end, and this is where things get really interesting because this is actually where the crux of cloud computing resides. Now, all processing occurs in the back end. And server farms and data centers, these are the places where you're going to find racks of thousands of machines. So when you log into a cloud service, you're actually porting in to gain access to these machines. I highly suggest you Google data centers and server farms and have a look at some of the big ones like Google or Facebook or Amazon. Now, depending on what these servers are purposed for, they can actually be dedicated to the provision of a cloud service application, such as storage or providing computing power, or even just executing tasks. Web servers are an example of one of these, and they deliver web pages to computers. File servers, they store data, such as music files and videos, and application servers host applications. Most often, a server will be dedicated to the specific purpose, and many servers will work together to provide a cloud service. As one server does a particular task, the computer network is streamlined to solve problems because each one solves a particular problem. But as the network grows, more servers are needed to carry out more tasks. And this is where an interesting concept of virtualization comes in. This allows a particular computer or server to host a virtual server. So instead of as functioning of a computer, the virtual server functions as a completely separate device. So kind of like just, it creates a separate entity. Virtual servers allow cloud computing servers to handle increasing amount of tasks while maintaining a fixed amount of hardware. And this is really useful. It's essential to cloud computing, as well as multi-tenancy. And this allows multiple users who do not share or see each other's data, but they can share the same applications, or they can share the same server functions while running on the same operating system, using the same hardware and the same data storage mechanism as someone else. And when you think about it, this is essentially like, imagine you've got to provide housing for a number of tenants. You could provide a separate house for each tenant, but then it's going to cost more because you're going to have maintenance for each house. Each house is going to have a roof, it's going to have plumbing, it's going to have electricity, it's going to have its own mailbox, everything is going to be individual. Or what you could do instead is house everyone in the same house, but they've got different rooms. So they share a common infrastructure. Maybe they share a bathroom and a kitchen. It's actually a lot cheaper to look after all of them than it is to look after them all in separate contained units. And this is essentially multi-tenancy in cloud computing. And it makes it cost effective to provide specific resources, whether it's computing, networking, or storage, to a much larger group of people than it is to one individually, and they just share common resources. I hope I've simplified cloud computing for you, and at least you understand the basic concepts through the front end and the back end connected by the middle, the network and the internet. Thank you.